As we have seen, mathematical statement has mathematical content. That's what really is in the foundation of mathematics. So we have seen a lot of examples in the last chapter in logic of statements that can be true or false. If you have mathematical statements that have some important or useful content, then you often call it a theorem. So mathematics is built up of different theorems. And you also have definitions. And for example, a theorem is there are infinitely many prime numbers. So that's a mathematical theorem. It's either true or false, but then it has been proven to be true. So that's a mathematical statement. A definition is, for example, that if I work with the function, I say, okay, f of x now is equal to 2x plus 1. This is not a statement, it's just a definition. Or if I say, I can define as even number is a number that I can write in this form. So even number, I can write like that. These are definitions. It's not something you prove. It's just something you define. So you have theorems and definitions. Some theorems you want to prove. Other theorems you can't prove. You start with accepting those theorems as true. And that you call axioms. So theorems that you just accept to be true without proof, that you call axioms. So you don't prove them to be true, you just accept them as true, or you have as a starting point. Okay, let's say that these holds. These are the case. What then follows from that? So this is the starting point, because you can't prove everything. If you want to prove something, you need something else to prove it. So if you don't start somewhere, you get an infinite chains of things you need to prove. So if I want to prove theorem 1, I need another theorem 2. But to prove theorem 2, I need another theorem 3. So you have to start somewhere. So you start with theorems that you just accept to be true. For example, in Euclidean geometry, you started with that through every 2 points, there is exactly one line going through these 2 points. That was an axiom in Euclidean geometry. So you just accept that to be true. You don't prove it. So you have those starting points are called axioms. Then from axioms, theorems, and definitions, you build up the whole of mathematics. So at its foundation, you have theorems, axioms, and definitions. So you can write it schematically like this, just simplified. So you have some axioms. So you have several axioms, and then you have some definitions. Just showing a few here. Then combining these, you can prove theorems. So prove is to make logical conclusions. You argue logically from these, and from only these it follows logically that these must be true, this theorem, for example. So if you combine this axiom and use this definition, then you can prove that this is true. So let's say that's the case. Then these point to that, because these 3 implies this to be true. Or you can have another theorem, and that could be perhaps be proven by using that axiom and these 2 definitions, or these 2 axioms and this definition. And then maybe you can combine these 2 to prove another theorem. And in the proof of that, you also use an axiom or a definition. So you build up this tree of theorems, starting from some axioms and definition. That is how the mathematics is built up.